I'm always saying there is one Hettie in Postgres, and please call me Hettie. The thing which I'm trying to promote for many years now is the holistic approach to the optimization, which means it's not a database alone, even not operating system and database alone, but operating system, database, and application. So it started as an example, because first, when it was not NORM and it was this Hettie's JSON thingy, I was presenting a lot in different conferences, and people were asking me to build example and just to show how it is done. Then we started this new sub-project, which is NORM Gen. And if you actually go to NORM Gen subdirectory here, that is what is NORM Gen. I'm glad that people are interested in what I'm going to talk about.
Well, hello everybody, and welcome to another Data and API show. It is really great to have you all back again as we continue on this series all about databases. We've got BigQuery, we've got Postgres, we've got Microsoft SQL, we've got so many different kinds of databases. But what's near and dear to our heart here at Hasura is getting back to some of our original core databases where we'll always have a soft spot for Postgres. And if you know anything about Postgres, or you're part of the Postgres community in the US in particular, you are probably familiar with the work of Hettie, our guest today. And I'm super excited to have you with us today. It's good to see you. How you doing today? You feeling good?
Yeah, doing good. Thank you for inviting me. I'm thrilled to speak at this show.
Yeah, we're thrilled to have you. I mean, the content you've been putting out for years at this point around databases, around schemas, and we're going to talk a bit more about some of the newer thoughts or things that you're pushing out lately later on. Is really, I mean, you've been in this game for quite a while, and going back to Oracle, I believe, right, is where you kind of got your start, and so. Really great. So why don't you give everybody here who's not familiar with your work a little bit of a background on who you are, what it is that you do, and we're going to kind of kick off from there.
All right. So hello again, everybody. And so I'm glad that people are interested in what I'm going to talk about. So my name is Hettie. My last name is long and unpronounced. So I'm always saying there is one Hettie in Postgres, and please call me Hettie. So I've been doing databases all my professional life. So now it means it's like 39 years from now. I'm always saying people do not live that long, because recently when I joined a company, it's like median age of my coworkers is kind of like less than I've been with databases. So I feel like everybody's mother, everybody's grandmother. So I've been doing databases since I attended the university, and I first read a book by Chris Date, Introduction to Databases, and I'm like, oh my gosh, it's so cool. And that was so new back then, in the 80s. I want to do it. I want to do it for the rest of my life. And interestingly, I am doing it. I think now, I'm approaching retirement age. So I guess for all my professional career, I'm doing databases. And okay, so I started actually before relational databases, because in this first said book, which I read, it started from relational theory, because Chris Date came up with this. But this first chapter about relational databases ended with a paragraph. So it's nice and cool theory, but it will never go to industry because it needs too much main memory. Okay, so I started from hierarchical databases and from other non-relational model, and now look, oh my gosh, okay, it is industrial standard. My current database of choice is Postgres, but I worked with everything in between, including actually many years with Sybase and many years with Oracle. And when I started Oracle, it was Oracle free. People don't even know that Oracle free existed, but it did exist. And I was with Oracle for 15 years, I think. And like many other people, I thought that Oracle is that is a relational database, period. So when I was offered a job with Postgres, I was like, what is this? Let me try, and then I will probably go back to real stuff. And then I loved it. Oh my gosh, like several months later, I loved it. And then I like, oh my gosh, that is so different, so cool. And I'm all heads to heels into Postgres. And it went so far that not only I've been doing Postgres for a while now, but also I'm a local organizer of the Chicago Postgres user group since 2017. And our group is one of the largest Postgres user groups in the Western Hemisphere. I think it's second largest in the Western Hemisphere, and we survived pandemic. So that's pretty much what I'm doing. And another thing, probably worth mentioning, unlike many other database people, I love working with application developers, and you won't hear this often because most most database people do not like application developers talk to any DBA, right? Like, oh, they are just doing this and that, and they're out of control. I actually love working, and I believe, and it's not like recent. I believe that for most of my professional career, when we started to have this separation, application and database, because in the beginning it was a program. Okay, so since we started to have it, I firmly believe that the road to building performant application is going through successful integration of application and databases. So the thing which I'm trying to promote for many years now is the holistic approach to the optimization, which means it's not a database alone, even not operating system and database alone, but operating system, database, and application.
Yeah, the full picture is really critical. You know, you have to, it's not just about how you store something, it's also about how you ask for it. It's not about how you ask for it, but also in the language you're speaking to ask for it too. So yeah, we're going to get into all of that. I'm going to take advantage here a little bit of some of the roadmap and the history you've had. So what was it? I want to kind of go back to when you said that you got super excited about databases when you first read about them. I mean,
Mm-hmm.
for I think a lot of developers, the idea of reading about databases as the new thing probably sounds a bit foreign. But like, what was it that really caught your eye about this paradigm called databases, and like, what was it that people did before for storing content in a way, like, just so there's a bit of a kind of a bit of a history, because I think it'll play into what's informed the latest thing you're working on. And so I kind of want to ask a little bit about what was it that really caught your eye about this about databases in general when you first started.
Yeah, thank you. Now, that's a great question. People do not want to hear about history most times, so thank you. Databases are beautiful. They're very logical. They're very mathematical. And, I studied in high school. I attended high school with advanced program in mathematics and physics, and I was all into math. And there was no even such a thing as computer science. So when I started my studying in the university, it was math pretty much. And then, there is such a thing as programming. There are such things as mainframe. There are such things as punch cards, and there is a line to the punch card machine and the line to get your listing back and all this stuff. And so actually in the early history, there were no databases, and we have a program, and the program was the main thing, and program would read data and output data. Okay, we had like punch cards and we had listings, and program was the main thing, and data was like not important. So what happened when databases came along is data became an important thing. So now we have data storage. Data become like the main thing, and there are program coming in, putting some data in, programs coming, getting some data out. So it's kind
So
of like this.
originally it was like the most pure form of functional programming ever, because you were bound by, like, you would only have your inputs and an output, and there
Mhm.
was no side effects, there was nothing else, there was no storage, there was no internal
Yes.
memory or
Mhm.
anything.
Mhm.
It was just
Yes.
what you would create. And then the existence of databases then allowed this idea of essentially what we even refer to today with like step functions, when it comes to sort of this functional concept, where you can say, I'm passing the result at some point of something I've
Mhm.
already processed, and now I'll be able to actually go ahead and use this again for the inputs of
Yes.
another function or other function. I mean, this is foundations of programming today, but like this was a relatively new concept because you would have to run a
Yes.
program, get the
Mhm.
output, write it down
Mhm.
somewhere, and then use that
Yes.
as an
Yes.
input again. And there was
Yes.
no,
Yes.
there
There
was
was no
just Jeff and
persistent
accounting.
storage.
There wasn't a database.
Yeah, there was no
Yeah.
persistent storage. And remember, first storage we have were magnetic tapes, and like try to read something from magnetic tape, kind of, roll it to this place. And when direct access storage came along, it was a revolution, actually, that you can actually have a disk, read the disk, and like put this reading like heads to the place where you actually want to have this data. And I still remember how these physical disks look like. I remember when mounting disks, I would come to the data center, I would take this disk and I would actually mount it. That was like my disk.
I
It's
mean,
not the
and
command
for my
unit.
generation, it's like, okay, whatever the MNT folder is, like, okay, mounts, whatever, okay, I mean, like we get taught it and we know it now, but like it is just, it's funny where you can see the artifacts of history moving forward. And I think this idea of like the placing of data, it's actually really interesting because some of the latest not latest but some of the current bits of database optimizations, which is actually really really old stuff that's coming out in the Postgres scene in particular, is now a lot about, well, actually column order is actually really really important when it comes to optimizing databases. So people are talking about how having variable length characters in columns at the beginning of your rows as opposed to towards the end of the rows will actually impact a lot about your optimization, because the database is trying to figure out, well, how much space do I have to allocate to maybe simple integers all first and big massive integers are at the end, and I can kind of optimize space a lot better that way. So there's some that actually goes back to these old tape days of like, you really had to think about this stuff as table stakes to just work with this stuff. And now it's sort of people saying, well, actually this kind of is all still the same. We just have gotten really lazy about how we added columns.
Yes and no, because actually, obviously, disks became like nothing what I had when I was a student, and we have way better capabilities of accessing data on the disk. And honestly, yes, optimizing things the way which you mentioned, it's important, but also even if you do not do this, that's okay. And often we do not know how data is stored. So that was my kind of next little or big revolution, because for a while I knew actually how data is organized in disk, like from Adabas Natural, even from Oracle. You could see like the map of the disk, you could see where your table is sparse, you could see how you can and then when it came racks and like, oh my gosh, and they're like, those rates, I do not even know where is it. I do not know anymore, because they're actually stored in all different places. And now go to Amazon, go to AWS. You don't even know
which country is my data in is a hard enough question
and
sometimes.
yes, and how many real databases are actually working at the same time in your allocated machine, and like, oh gosh, it's just
Yeah. So you love this idea of the structured data and the ability to persist content, and the idea of being able to essentially save work that's been done,
Mhm.
transporting of data. You moved on to then, obviously moving towards more of a non-structured system, because relational, again, wasn't going to scale for enterprise. And when did you make the switch to then relational data? Where was that switch point where then you realized that actually relational data really was taking off for the enterprise, really was something that was going to be powerful? And what caught your eye about that made sense to you as a mathematician or other pieces there?
Now, I knew right away that that was super cool, and like relational theory is just so beautiful. I mean, like seriously, like look, it's so beautiful, so logical. I just loved it. But I like, yeah, it's not going to work. So I worked for a while with Adabas Natural, and that is the system which was like partially relational also with some pointers, with some references. So I actually love the relational part of it. And then came one of the first Oracle version, which was like, oh gosh, you would not like to work with this because it's like extremely unstable. But you can actually like type, select star from something like, so, like so cool. So honestly, I like. Okay, so I came to the United States in 1996, and before that, it was basically okay. I worked with whatever database is available, whatever my client, whatever my employer has, I will work with what they have. And there are all sorts of things. There was a little bit of Informix, there was a little bit of INAS, there was actually University Postgres at some point, but that was like Michael Stonebreaker Postgres, which was again super cool because you can actually write select star from something and get results. But this was again not really industrial. So first industrial relational database I worked with was Oracle 6. So it had pretty much everything except of functions and storage procedures, which is my favorite topic. And then so when I came to US in 1996, the database was Sybase, and that was new exploration. And I got all into new concepts, and I just became proficient. And then my CEO asked, so Henrietta, did you hear about Oracle? I like, yeah. So, our investors think it would be a good idea to migrate to Oracle. Like, yeah. And then I've been Oracle for a while because Oracle, Oracle was such a big deal. And honestly, I think the best and the worst part is that you grow to this like, feeling that Oracle is a relational database. So whatever is good for Oracle, good for relational databases. So you lost touch. It's not really, and even Oracle SQL is not 100% standard ANSI SQL. You're like, okay, I know everything about relational databases. I can teach classes. I can onboard new consultants because I know. And then you come to Postgres, and Postgres said, you think you know. Like, no, forget about it. It's like, oh no.
Where does that divide occur? So I mean, I've said this probably in every show so far. I'm not the most databasey dev ever, and I'm trying to learn. So like, where does Postgres make hard and fast rules, which has probably led to why it's been so stable and predictable and safe for data? Where does it differ to then be considered a true relational database, whereas something like Oracle was relational like?
No, I mean, they are both relational. It's just the way how this relational engine is implemented. Because what is good about relational databases, right? They are declarative. So we have this concept of declarative language. When you write select star from employee where like whatever, you are not telling, okay, you need to go to this table, like use this access method. You're saying basically, I need to get this data. That's declarative. And what is inside, that's what's different. That's why people often get confused. Oh, SQL is SQL, SQL is SQL. And okay, SQL, there's standard SQL. There are some little kind of off-standard things, both in Oracle and the Sybase, in Microsoft SQL Server, and in Postgres. There are some little things which are off-standard. But the interesting part is not how SQL looks like, but how things are implemented. So with Oracle, I mean, Oracle is a super powerful system. Like I'm not saying, oh, I do not like it anymore.
Yeah. No, I mean,
It's
people still use it. Yeah,
yeah,
it's
absolutely. People use it, and I talk with people who use Oracle like often, not every day, but quite often. There are lots of things which kind of lots of internal details which were implemented to make something better and then something better. So my feeling is, and that was even before I switched to Postgres, Oracle became a little bit overloaded with some extra features in terms of how things are implemented. For example, like one of the biggest differences is Oracle uses optimizer hints, right? So basically what it means, you can tell Oracle, when you execute this statement, do this. Just whatever you Oracle think, I don't care. Just use this index, join these tables first because I know better. Postgres, you cannot do this. So that was like first thing. You come to Postgres, it's like, how I'm going to write performance queries? I do not have hints. How I can tell Postgres what it should do? So Postgres Optimizer, honestly, is my opinion, the best optimizer for any relational system I ever encountered. And that's by design. So people who are working on Postgres, they just made this point, we are not doing optimizer hints, because you do optimizer hints, you become dependent, right? It's like a drug dependency. Then you need to change it, and then you need to make sure it's still okay. So Postgres uses everything it knows about data, about statistics, and it has very cool algorithms how to plan the query, how to optimize it. And that's what relational databases are about, actually. Yes, choosing what is the right way to execute. And it's like so powerful and so
Because
interesting.
it is a mathematical formula.
Yeah.
It is
Yeah.
something that can be optimized given enough resources that in theory there is an optimal way to access the data
Yes.
regardless of what's inside of the buckets. The shortest path between this and this will always be that in a truly relational way, as opposed to, I mean, think about an Excel spreadsheet where you've encountered somebody who has formatted it, put a couple of cells around the sides of the spreadsheet or something because they're trying to optimize for read access. That's,
Mhm.
really course level analogy here. But like, then you break any ability to use any developments or evolution of Excel in the future because somebody has changed the nature of what a table is for optimizing for something else. So adding in these hints or saying, I'm going to sort of
Mhm.
shortcut the way to read something or to optimize a path, you just don't have an upgrade path. There's
Yeah.
nothing
Mhm.
predictable there
Mhm.
for the company or even for the advancements to say, we know how to make this faster or better, or be able to offload compute to some other resource that will now make something previously that we didn't think was going to be doable now
Mhm.
doable. Okay, that's interesting. So being so strict about
Mhm.
not letting you have escape hatches has led for a predictable platform of evolution and development in Postgres that benefited from the
Yeah.
increase in compute, increase in memory, increase in everything else. Whereas there's now a larger backlog of, one-off queries that are critical to people's companies that they can't easily update without going in there and undoing all the hints and then
Redoing.
unmapping all this work that people have done to the application layer that was based on a brittle
Yes.
Jane Doe wrote this in a bad way, or wrote this in the best way she knew how at the
Yeah.
time,
Yes. Yes.
based on
Absolutely.
the current environment. But
Yes.
that could not be updated programmatically, and
Yeah.
could be
Yes.
thousands of queries. Yeah.
Yes. Yes. And that's, we often see when people like organizations migrate from Oracle to Postgres. So they migrate obviously because Postgres is open source and Oracle licensing cost. We all know how much it costs. So they are migrating for cost saving. But then interesting things happen because again, SQL is SQL, right? And there are lots of programs, like lots of companies who help their clients to migrate from Oracle to Postgres. And you can use, for example, the same function. There are like very minimal changes to the syntax. It was Oracle function, it will be Postgres function. It would not work the same way, and people are so disappointed. I heard from one company whom I was like consulting, helping with their migration, like Henrietta, we've been optimizing it for Oracle, as we now know, because they thought they were optimizing period. We were optimizing it for Oracle for 10 years. And now, like in 6 weeks, we need to re-optimize it for Postgres. So yeah, that's
Yeah,
very
SQL is SQL makes about as much sense as saying English is English until you try to order a beer in Scotland, and then you remember, people have different ideas of what English actually is depending upon where they it evolved. So
Yes, and
yeah,
like for example, I can give you example which actually comes from our training database of when I and my like co-authors we wrote this book PostgreSQL query optimization. We created a training database which is available open source Postgres Air, and people can use it for training, for like working on optimization. But one example which I like from there, so we have airports there, and all airports are real airports, and we have like airports, countries, and flights. Okay, so when you run a query which selects, for example, airports in the United States, it would not use an index. It was useful scan because it's like a whole bunch of airports in the United States. When it looks for the airports which are in Czech Republic, there's just fewer airports, and it will actually know to use the index because, and we did not tell anything, we did not put any hints, but
really,
Postgres, yes, because Postgres
how?
can. How? Because we have statistics, and Postgres looks at the table statistics and index statistics, and it knows which path to choose. And that looks like magic. I have this example in the book. I just, okay, run and look and try and see. Like I'm telling the truth. You do not need to do anything. Postgres would know better. So most time people are, why Postgres is not using my index? There might be a reason. Let's see. So you think you should index by date, right? And you have like table of invoices, right? Maybe like millions of invoices. Okay. And how many like days, years, months? Okay. So you have 2 years of invoices, lots of invoices. Okay. 2 years, it's what, like 730 days only for like 10 million invoices. You really think Postgres
That's a
will ever
lot of
use this
shared
index?
indexes. Yeah, yeah.
Nah, like, no, it won't. Like that thing. So lots of these things, like Postgres does right most of the time. Most of the time. But yeah.
That is really interesting, and I think that there's so I think this is going to be a nice segue to talk about a little bit of what it is that you are working on, because
Mhm.
so some of the case then where we've seen the rise of Postgres tooling and schema tooling. So Postgres does not give you the breakout box for data access, for querying around and saying, okay, I'm going to choose, like, when I select, I want you to select this table first, and I want you, like, they don't have the hints like you were saying. I think
Mhm.
that has provided a lot of strengths. People still want breakout patterns and escape hatches, and those have evolved more, I would say, than in the shape of the tools around initially setting up those Postgres systems, which has brought us to a world of Postgres is sort of the last to know what your schema is going to be. In a lot of modern application development, we've seen a rise in a lot of like ORM-based tooling that has
Mhm.
said, okay, well, for us to be able to at least reason about our data structures in a way where we feel like we have control, and we can kind of control the flow of how these hierarchies are created, or these relationships are created, we're going to go from sort of a code first approach to defining our schemas, which provides a level of optimization or hinting to Postgres to say, hey, this is my join table, and this is my primary table, and this is how I want you to basically access this data. And you've actually got some very specific thoughts around
Yes.
the space about using tools like these ORM-based development versus non-ORM-based development. Let's dive into that. So it's a bit of a rough connection here, but like let's dive in a little bit into this rise of ORM-based development that we've seen as people have tried to use more. I would say, I'm referring to this as an escape hatch to sort of influence how then Postgres is set up, because people wanted to have more control in how the end product looks or is even accessed. So what's been your complaint, or the latest thing you're working on, and then let's explain what the problem was that it was trying to solve.
Okay, so actually I'm going to piggyback on you just said, because you started to set hierarchy and then you backed up. And that is very characteristic because people think in hierarchies, and object-oriented application thinks in hierarchies because that's what we do, okay? We see something on the screen and it had to be like something hierarchical. Relational databases are not hierarchical, and we can build multiple hierarchies on one data, like on one set of data. Like, for example, looking at this, our PostgresQL database, you can select all the reservations for one person, and that will involve airlines, flights, tickets, like boarding passes. And this hierarchy will start from the person, go to trips, bookings, go to flights, and go to boarding passes. Now, when the plane is about to take off, they print a manifest. Manifest, those are like all people, all their reservations, all their seats. Same data, it's different hierarchy. It starts from the flight, and it gets to booking, and then gets to people. So different hierarchies can be built on the same data. And the thing with ORMs, and when we start from program, we actually lose this flexibility of building different hierarchies from the same data, and most times we need different hierarchies for different usages. So the other thing is that, yes, when we use ORM, we cannot really control what is happening on the database side, right? And okay, let me actually kind of go a little bit back. So why people use ORM? People use ORMs because SQL is difficult. SQL seems easy because it's just one statement. Look, what's other language where you literally have one statement? Select, nothing else, right? Oh, okay, except for updates, inserts, deletes, but just select. So it looks like, yep, I know how to write grammatically correct select. I can do it. But actually SQL is difficult. And people don't want to spend time on designing it. So ORM kind of bridges this gap, so you can build database, you can use database without knowing databases. And this works perfectly fine for any MVP, for like anything. Okay, you like build fast prototyping, it works. All right, now we are putting it to production because it works, right? And what was designed, how it happened, it doesn't matter. And I mean, it's logical to some sense because people's time is most valuable asset, right? In the dawn of databases, it was like memory is the most expensive thing. You could like sit, spend time coding to minimize usage of memory. Now people's time is most valuable asset. So everybody want to save time on development. And ORM gives this revenue. Okay, you can develop very fast without going into details. So, and it works great for MVPs. So what we get then, we get suboptimal data access patterns. And then the product is already in production, data start to grow, and we are getting application which starts respond slower, and then what we're going to do. So interestingly, when it was like in, I think, 2012, yes. So I was with the company, which was not exactly a startup, but kind of like just about to go public. And we had this problem. Application was slow. So some pages responded like for 20, 30 seconds, like horrific. And person who reached out to me, not the DBA, not application developer, was hardware engineer. Because he came to me, he said, Hettie, look, we cannot procure the hardware which would be fast enough. He just brought me numbers, like if we will purchase this, and we purchase this, it will purchase the most, the best storage available in the market, it will cost like 100 times more than now, and we will only increase performance twice, and we need to increase performance like 200 times. So, and then yeah, okay, let's see what I can do. And then I started this development, which was taken with a grain of salt because it required people to change the way how they think, the way how they program. Nobody likes it. But at some point, you just are faced with these numbers. I had a funny conversation the other day, like actually recently on LinkedIn, because like I was talking about functions and about how they help to speed up applications, make them performant. And like somebody who was replying to me, they said, yeah, but then it's better to like how he put it. So basically to put several servers working in parallel, and then like, wait. You still need to access the same data. You cannot read less data. He's like, we're talking about different optimizations. You are talking about database access. I'm talking about like CPU. I'm like, look, I am talking about costs, like material costs, not about the cost of accessing data. I'm talking about how much money it will cost to keep up with the data growth in this system. So is it like linear growth? The more data we have, the more money we need to invest in hardware, or it will be logarithmic growth. It will be growth still, but it will be like way slower. So that's why I think sometimes, or most of the times, until it comes to the actual cost, how much it costs, people kind of don't care.
Yeah, I mean, that'll always be the so we've got multiple themes here, and I want to stick with the ORM bridge
Yes.
we're on right now, but it does talk a lot about your overall focus on a holistic approach to optimization, because it's not just about like the data I have today. It's how will the way that I access this data scale with the scale of my data as I get more and more of it. And that's a part of this holistic thinking, is that, okay, it's not just about as I increase storage as a total, do these access patterns scale as well? I was to try and bring it back to the ORM conversation. I was listening to a Postgres presenter, and I'm wishing I remembered his name. I'll try to pull it up. But he was talking about one of the complaints he had with ORM development is that when you have like constraints that are generated by Postgres in many cases for things like unique keys or whatever else, having a violation on unique key, slug on user must be, whatever. Like you have these identifiable names of where your uniqueness violations or your numerality and things disagree in your data model when you try to insert something. When you have an ORM model that you've deployed, you're going to end up with something that's kind of like violation 12x45 789, like these unique IDs that are generated by these ORM tools. They get mapped to violation constraints, and it's like, well, what was the problem? where was this constraint? Where was this violation? Because you're not allowing the database to provide sensible, reasonable names, and you can even then override those names in cases where you have violation constraints. And so I think that's a case where allowing the database to work with the database as a tool instead of, again, trying to, I think that's probably the trend line here, is that between, providing hints to a query language, or even trying to force a relational database to be designed from a hierarchical perspective, in both cases you are not working with the database the way that it's designed to be worked with. You're trying to force the tool into a shape that it's not intended for. And I think that's sort of where then these things start to fall off the lines, because, like, just coming from the Hasura perspective, is when you allow the database to be as databasey as possible and as predictable as possible, then Hasura from our side is able to surface all of that in a really, really elegant way, because your data model is clean, your constraints are logical, your data flows make a lot of sense, and GraphQL doesn't really care about, a hierarchy in terms of the mapping over SQL. So I think that's an interesting piece here, where learning how to work with the database in a way that is designed to be worked with yields dividends for how well it's going to be performing. So you've got this this reasoning why you don't like ORM development, because it's creating bad access patterns, oftentimes stemmed from hierarchical thinking and people trying to access data in a way that the database is like, well, I could access this data faster another way. So what's this content? What's this thing that you're working on? Because you got a pretty neat name for it that you've been working on in terms of your anti-ORM march here. So what's the what is it you've been working on, and kind of give us the rundown on what thinking is?
Yes. So the name is NORM, and I came with this name after several years when people were saying, this Hettie's JSON thingy, like literally, this Hettie's JSONs. And like, I'm like, okay, so there should be better names, like this Hettie's JSON thingy. Then actually, when we came up with this name, it was kind of a peak of hype of NoSQL, when one more time, each like couple of years it happens, like, relational databases are a thing of the past, and we have something better, and we have NoSQL. So like kind of alluding to NoSQL, we decided to call this JSON thingy no ORM, and then it goes to NORM, and then it's like our new norm. That's how we want databases and applications to interact. And then finally, now actually people finally know what NORM means. So now I talk to people, and people started to kind of recognize this name. So, and then now
you have a repository, right? But it has some of the thinking around it.
Yes.
Do you mind sharing your screen and showing us what you have there? Or
I mean, okay, let me first like talk a little bit, and then I will share. Okay. So what is it? So like why we started doing this? We started doing this because I like use my approach, and then people were saying, you know what, it's super cool what you are doing, but then we need to write code, functions, and then we need to have Hettie everywhere we use it. So this is not working without Hettie. And then I like, okay, so let's do automated Hettie. Let's actually develop the real methodology, how to do this. And the critical part of what we are doing here is that the exchange of data between application database is done in complex objects. So what is bad about ORM? That we disassemble complex hierarchical objects from the application, send a small request to the database, and on the database side, we again kind of like reassembling or not reassembling, so we cannot run complex queries. And same on the way back. So there is no way to, the exchange of data goes on the level of tables and attributes. And both application and database can build complex objects. They can build sets. You do not need to go like from one person, from one account, and one by one pull all their orders, and for each order, one by one, pull their ordered items and like their shipping history and whatever. We can, absolutely capable, running one query. That's the user ID. give me all the order history. That's one query, one interaction. That's what makes it fast, because we are losing time, not even on running queries, but on all this, like, some applications have like several hundreds, up to 1,000 database calls for one screen rendering. Can you imagine this? Like, between you hit OK.
I can. I'm a GraphQL evangelist. I know. Yeah.
All right. So the idea behind this was to stop this going back and forth. We know how to build complex objects here. We know how to build complex objects here. So let's just come up with the way of interacting in terms of this object. So that's the essence of NORM.
So we've got the NORM project here that is shared, and so talk me through what is it we're looking at here.
Okay, so here is actually, README thingy. So it says what is NORM, and it basically says what I just told you, right? So it started as an example, because first, when it was not NORM and it was this Hettie's JSON thingy, I was presenting a lot in different conferences, and people were asking me to build example and just to show how it is done. And then we built example. And then when all this conversation started about we need to automate Hettie, then we started this new sub-project, which is NORM Gen. And if you actually go to NORM Gen subdirectory here, that is what is NORM Gen. So that is the set of like functions which allow you to generate functions. And what is here? So there is an example, so what you'll need to do if you want to try it, you need to obviously clone this repo and run the load all. It will create all these functions. And then there is like a little demo, which is a TS all call. So this one calls all these functions and creates metadata, and you can analyze hierarchies, and then it will just basically create all the functions. So what we can see just from the repo, how we communicate between the application developers and database developers, because we were always saying we want this to be kind of like it should be a contract. Okay, it should be a contract, how like there are contracts in object-oriented programming. It should be a contract between application and database. And before NORM Gen, this contract was in the name. Okay, so we define a JSON, how it should look like, and how we do this data interaction. JSON is not a contract. It's like an example, right? So what you can do here, and give me one sec, because I will actually open the same thing on my other screen, and I will tell you where to go. So in NORM Gen, there is okay, there are usage examples, okay, and there are 3 files with which have like JSON extension. So maybe the easiest one is the user account. So if you open the user account, so you will see an example of this JSON definition. So this is the file which what we think. So application developer basically tells database developer, that's what I want to have. So we have here user account, and we have a link to the definition. And then we have JSON keys DB mapping. So here, database person can fill them in, and there are lots of defaults. So for example, if there is always one database schema, here is database schema norm, then we just do it once and we never repeat it. But some tables, maybe from different schemas, then we define it there. Then if the name of the JSON key is the same as the name on the database, name of database column, we do not do anything, just by default, it's the same name. If it's something different, then we explicitly define database mapping. And then if you can like go on and on, you will see how we define all the objects and how we pull the descriptions from the lookup tables, etc. So this JSON defines user account. User account has username, user's first and last name, date of birth, and it has the set of phones and the sets of emails. And then you can exchange, you can communicate between application and database using these complex objects. For example, if you want to see all users, I don't know, okay, do not do all users in the state of Texas. We did it. It takes a while, and application will just die. But you could technically pull all users from the state of Texas. So you can pull all users which reside in some specific place. You can pull the users which has specific phones, specific emails. You can search for duplicated emails. So in any case, whatever query you create, you can pull all these hierarchies. So again, the key thing is that you always get the whole hierarchy back. And actually, there is this TS call also. Let's go up to the norm gen from these examples. And you can open the file TS call all. And in the beginning is the same JSON because we pass it. And then we execute this creation of the metadata. And then you can see that we can create database types, and we can create database functions, and then we can test database functions. So basically, if somebody would just install it and run it, they can create all the functions and they can test how it works. Like, for example, if you go, it's line 198, account search generic. So this gives you example. You can pass to the database all parameters, like whatever you want to search, and it will return for you the object which has all this, which satisfies all these criteria. Okay. And then there are several other calls here. It's starting from line 223, account to DB. So that is like a universal data converter. You can insert, you can update, you can delete, and you can do all of this within one function call. So here in these examples, you only insert one, but you can insert several users. You can update several users. So pretty much you work on the screen. You can pick up the work from the screen, send it to database. It will do all inserts, updates, deletes, including updates of the dependent objects, and return the updated results.
So where this varies then from the traditional ORM type approach is that this is more like an SDK of types for creating the definition of what the database should be from the way that the database is intended to be used, and
Yes.
then it's essentially working with those type definitions as the access pattern themselves. So this is becoming more like a SQL SDK than an ORM modeling primitive.
Yeah. So critical part here is it's still easy to use by application developers because they still did not need to know anything about databases, right? They need to know which objects they need to receive. And by the way, we intentionally made this syntax of the queries like copying MongoDB syntax. So everything which Mongo has, we have plus something else. Because
really? So it follows the Mongo primitives here. It's quite interesting. Yeah.
So that literally people do not need to know this Postgres inside. But on the other hand, so functions which are generated this way are pretty performant. But if for any reason we need to change something on the database side, we can do it within functions. And again, nobody needs to redeploy to make any changes to the application. Like, for example, I don't know, we found out that we need to partition some tables, or we need to do something else. We need to restructure them, whatever. So application can keep functioning, and we can improve functions inside, like after the functions are generated, if for any reason we need to make them more performant and we need to change something in the SQLs which are generated automatically, we can always do this. But it's a kind of different level of expertise. You do not need a database person to write everything.
Yeah, so this is really interesting because it's a little bit interesting because it's solving a half. So I mean, Hasura has taken a very similar approach where we use GraphQL as the query language for getting the databases. So we said, okay, from the querying side, it's still using very much the same concept of a shared object, which is going from the application developer to the database and then being broken down into the queries. And so in that case, they're rather duplicated. In the terms of defining and setting up the actual database, it's really interesting to be able to actually use this sort of it's almost like scaffolding the database from a query, saying this is the query that I want, and so build me a database that's compatible. and
Yeah. So
yeah,
it's not like we do not need database developer. Somebody still need to design a database, but
let's
like very
created an
people.
abstract syntax from merging the select statement and the create table statement, sort of saying these two should stem from a similar beginning point, which is really a fascinating angle. And frankly, even with the way that we've developed the latest Hasura data connectors, one could actually create a wrapper for even this component of it and be able to right away benefit from an existing system using NORM today, and be able to plug that into Hasura because they could write a wrapper for this. But this is a really interesting approach. You can see how that path from understanding the difficulties of, or I'd say appreciating where a database evolved, what the path of its history was, and figuring out, okay, the database by itself needs to be utilized in the way that this database was designed, and allowing the database to not be given escape hatches or any way that would allow for unpredictability from one database to another database. It should be standardized in terms of how people can utilize this, which is why Postgres has done so well. But then to be able to say, okay, we still appreciate SQL is difficult or is very obtuse for people to grok at times. So how can we find a way to create databases and allow the application developer to be able to work with those databases in a way that takes advantage of how the database was designed, as opposed to, well, we're just going to force the database to reflect this data model it's not designed to handle, in the case of hierarchies, or we're going to force it to the application developer to learn SQL. So you kind of have these two halves. In this case, we're saying, well, let's take some of the better parts that we learned about from how the application developers like to work. Can we abstract some of that? Because that's why Mongo took off so much. Let's take some of that and be able to apply that in a case where that helps us inform what the database, or allow them to take those primitives to model and design databases from that starting point.
Yep. No, I mean, and again, I'm not diminishing application developers in any way, shape, and form. They are doing things which I cannot do. And other thing, I have been always very clear on that database itself is not visible. Database is a service by nature. So end users see shiny interfaces, right? They do not know what's inside. When I talk to people who are like not technical and I'm explaining what I'm doing, it's something you do not see. You go to Amazon, you go to Expedia, you go to Travelocity, you go to whatever, you just type something in Google and the database is there. You do not see it. So application developers are our customers in general, like by definition. They're our customers and we need to provide them the way to do their job in the best possible way. That's how I see the place of the database, the goal of the database. Because database is invisible by itself.
Yeah, I think that's a really critical point, because I mean, with relational data, there are a lot of inherent values in just how things are. Like airlines, people, tickets, destinations, like that's not a Postgres thing. That's not a, and in a lot of cases, that's even not even necessarily an airlines thing. You know, the idea of location A, location B, and person going between them, and a way to prove that you have permission to train, like that's those are very highly abstracted models that just have inherent existence around us. And what we're able to see is that, okay, what's the best way for us to store those values in a location that allow us to accurately and securely pull that data out as we would need it. But then finding the story, like, okay, well, actually my service that I'm really providing as a business is, well, I'm going to let you see a whole bunch of potentials between these two places, and you can find one that works for your timing and
Yes.
convenience. Okay, well, we have a travel platform, or everything that you've done, well, now we have a cost center management platform. Like, so the way that we surface this data as application developers becomes, you know, part of the product story, but that still requires an underlying way to store and be able to accurately access this inherent relationship between data points that then we will enhance. And that's where I think, you know, from, again, speaking from just the Hasura side, like we understand there's cases where you need to break out of that box, and we have actions and things like that that allow you to handle some one-off business cases. And you can write functions too, like SQL functions. Like using NORM, you can definitely say, well, okay, we're going to write that one SQL function that does that one bit of magical math that adds some unique value proposition to our business. Those cases exist. Like, okay, what is the fastest travel time while still allowing me to travel between 10 a.m. and 10 p.m. and not doing red eyes or whatever? Like, yeah, sure, that's a value prop that a company may want to offer. But the fact is that the base of these models exists in sort of an inherent way. And what's the best way for us to be able to say, okay, as a DBA, what is the cleanest way to store this data in a way that creates this logical contract then for our application developer to be able to reason about it in a way that they are familiar with, without forcing the database to now do things or store data in ways that it's not optimized to do. I think that's sort of what the norm is. And I think, I mean, and in a lot of cases, there's a lot of overlap to what Hasura is doing as a product. But like, I think this concept is what's really, really critical, is this idea that, no, like, let the database be the database and allow this idea of saying, okay, well, we need to have a contract between the database and the user. For us, that's the schema to GraphQL, and we have this relationship there where we introspect and say, okay, that's the way that it works with our tool. But this concept is very critical to understand. Is like, look, the database evolved the way that it did for reasons.
Yes.
And
Absolutely. Yes.
yeah, and it's math, and it's like that. You don't argue with that. You allow it to store it in ways that make sense for a data storage structure. But like, we still understand that there needs to be a way to have this contract between the two that takes advantage of both. Yeah.
Yes. Now, contract is critical. So, I was very happy when we were able to kind of formulate it and separate that the critical part here is a contract. So we promise application, that's what we deliver, and the application knows what to expect. And I know that you guys are doing the same thing. That's why I was so excited when you reached out and, you showed me like one of your programs, and like, oh my gosh, somebody is actually doing the same thing and doing it so seriously. And like, I just was hooked right away. Like, no, I need to get on this show because these people are doing the same thing that I've been doing.
Yeah. Well, no, then we have to have you be able to go out and explore Hasura then, so we can have you on one of our Hasura cons to talk about, like, as a preacher out there telling everybody it's all about the contract.
Look, you know what? Sometimes I feel that I'm working on one project for all my professional life because I've been like trying to implement this concept everywhere. And somehow, previous times, I think when, again, databases were new, then people kind of believe that there should be people who know databases, who can do stuff on databases. And then when databases became not such a new, cool, hype thing, then it's like, why we need database developers? There are like lots of companies which exist without any database developers. And they think it's just, extra body,
Madness.
which they do not need. So, yeah.
Yeah, no, and imagine like I mean, in a high-end kitchen, there are people who specialize in the organization of the tools and like which ingredients are stored where so people can access them and being able to look at freshness of product. I mean, you have raw product storage is a very critical part of every
Yes.
single business and has been since the beginning of the idea of storing one thing and turning it into another. And so while you can get fairly far without a DBA, I would say 9 times out of 10, every time somebody comes to us at Hasura and says, "Oh, hey, your product's not very good because it's really slow," it's like, "Well, show me what your database looks like." And then it's like, have you heard of this thing called an index? Or like just really simple wins where it's kind of like, look, you need to understand again what it is that you're trying to
Yes.
be able to present. And so understanding databases on just a structural level, you don't have to be an expert in SQL, you don't have to be an expert in these things, but you should be able to understand critical functionalities of what a database
Yes.
is
Yes.
intended to
Yes.
do.
Yes.
And then you'll be just throwing lightning out of your fingertips because you just get a lot of value from that. And yeah.
Yes, most important, and unfortunately, some people lose this touch that database is not a sequential file. Database is the database. Database is a software which is designed for fast data access, designed for data storage, for efficient data storage and for fast data access. And these people, like the word from application developers, database is slow. Like everybody says database is slow. I'm like, application works fine until it hits database. Then when it becomes slow.
Yeah. I read the menu really fast, but as soon as I asked the chef to make it for me, it slowed down all of a sudden. Yeah, it's so
Yeah.
yeah.
So yeah, that's what I'm trying to educate people about. That's not database is slow. That what you ask, how you ask, and again, ORM problem. Do not tell database what to do. Tell
Yeah.
database what you need and let database deliver. Just do not tell it like, first you go here and you bring me here, first you go this and bring me this. You know how it's very good analogy from very old presentation of some French consultant, where he compared this approach to shopping. So you have a shopping list and you look at one item, jump in the car, go to the store, bring one item, bring it back, then look at second item and go go back. And no matter how fast is your car, and no matter how wide are the highways, how many lanes are there, that will be still slower than just bringing the whole shopping list back.
Mm. Yeah, absolutely. Absolutely. Hey, Hettie, it was really great having you on for this call today. Really, really appreciated it. Do you have any like 3 points maybe for our viewers of things to maybe look at or be able to advance their database knowledge, or what would be 3 resources that you could recommend to users if you gave 3 points for people to take home?
Oh my gosh. Uh, a very challenging question. Uh, I don't know about resources. I think okay. Uh, so recently there was one person is a manager and he asked me where I should look for new database people. I want to hire several database developers, where I should look. And I told him, look for recent grads. They still remember what is math, what is calculus. They did not forget how to work with data, because when they already been in industry for several years, most likely they're not getting first job as database developer because they're not that many. They get job as application developer, and then 3 years later they're engineers. They're not mathematicians. They don't remember this. So I think that a very critical part for understanding databases and work with them efficiently is remember that they are very mathematical. Like I don't know how else to say it. Just not to work with databases the same way as you work with programming language. Do not write database function the same way you write your like Java function. That different things. And otherwise, it's funny because people often ask me like what books to read and what something. I like as I said, I started before relational databases, so basically the whole database history kind of came, in front of my eyes, was developed in front of my eyes. I have zero certifications in anything because I was there when it was happening. Um, so like for Postgres, I would say people should try Postgres, and people should learn from community. Now, obviously, I can recommend my book, but I mean, honestly, this a book is for people who already know about Postgres and about SQL. It's like kind of like.
But yeah, plug the book. What's the title, and where can they find it?
All right, it's actually on Amazon. Just if you give
We'll
me
we'll put the links in the description. Just give us the title, and
yes,
so it's on Amazon, and the title is.
that's also that's PostgresQL query tuning.
Okay, fantastic.
Mm.
Hey, thanks again so much for joining the show today. This was really a lot of fun, just getting the history, seeing the process, and even though we've kind of developed parallel solutions to the same problem, it is I think something where there's just the fact of this contract between the two is critical, and that's where once you get that down, you actually have just an incredible development velocity because you've got the database doing what it was designed for, and the application developer able to work with it according to its terms, but in a way the application developer is used to working, not doing the 30 trips back and forth to the grocery store, but actually just saying, hey, here's the shopping list. Come
Look,
back and you've got it. And
I think it's not anybody's deficiency that you developed like pretty much the same thing, like like essentially the same thing. I was very excited when I realized that we are working on the same thing because that means that you can say great minds think alike, right?
There you go. If you can say that we're thinking a lot like Hettie, then that's a compliment. So we'll take it. We'll take it. That's going to wrap it for today's show. I'm going to go ahead and say goodbye to you all for this week. We will see you on the next week's show where we're going to look at more about databases. Next week, we actually have on data mocking and actually how to mock on production data for development sets, because I don't know, sometimes customers don't, or your customers don't want you sending real credit card numbers to development machines. That's just something I guess you don't do these days. So we're going to be talking a lot about data mocks, and we're excited about that topic. We'll see you on the next show, and have a great day, everybody.
Thank you. Thanks.